Hi, so today I will discuss the tutorial questions 1, which is institution behind the cost function. First of all, you need to know the cost function formula from what we have learned before, which is j theta naught theta 1 equal 1 over 2m summations of n I equal to 1 h theta as I minus yi power of 2, which is equal to m is equal to the number of training example. As shown here, the training example is 1, 2, and 3. So m equal to 3. Okay, next, as we need to know the key function, the two key function which is h naught and j theta 1, which is h naught is the function of x, while j theta 1 is the parameter of theta 1. So as the example, we need to predict the h theta naught xi, which is here. We have the yi here, which is 1. So as example, theta 1 is 0.5. So we put it into the formula j 0, 0.5 equal to 1 over 2 times 3, 0.5 here, and minus by 1, yi, power of 2 plus 1 minus by 2 plus 1.5 minus by 3 power of 2, and you solve this, you will get 0.58. So from this 0.58, you point it in here. So we get the parameter of x1. So you can continue with if the x1 equal to 1 to make your understanding better.
My name is Ainasim Firhat. My metric number is B0217102005. Okay, moving on to the second question. It asks about how the momentum affect the convergence of data. So basically, the question is all about the gradient descent. Gradient descent can be defined as an optimization algorithm which is mainly used to find the minimum of a function. Okay, so the momentum is the tendency of object to keep going in the same direction with the same speed. Or in the other word, it depends on the mass and velocity, and it also has a direction. Okay, so this gradient descent, it depends on the learning rate, which is denoted by alpha. If alpha is too small, the gradient descent can be slow. So many updates needed before reach the minimum point. Okay, and then at the optimal learning rate, which is alpha, it will swifting reaches the minimum point. And if the alpha is too large, the gradient descent can cause drastic updates such as these three conditions, which is overshoot the minimum, fail to converge, and may even to diverge. Okay, so basically, to see if the gradient descent is working, we need to print out the cost function of each iteration. So the value should decrease at each iteration. If it does not, we should adjust the learning rate.
Hi, my name is Nazarina Karudin. So I will explain on the tutorial 6 questions 1, which is gradient descent for multiple features. On this slide, it will show you the gradient descent with the linear with the n equal to 1, which is theta 0 and theta 1. Theta 1. So this one is the new algorithm for n more than 1. We will repeat the same equation for theta 0, theta 1, theta 2. So next, we will discuss on the feature scaling for gradient descent. And the feature scaling is necessary to make all the features in the same scale, which is in the not too big and not too small. So as example, in this case below, x equal to size 0 minus 2000 of it. For x2 equal to the number of bedroom 125. So first we use the feature scaling one, which is in the feature scaling one, the scaling is between 0 until 1 for both x1 and x2. There's another way to scaling the gradient descent, which is we approximate the gradient descent between range negative to 1. And next, we use the mean normalization, which is we replace xi with the xi minus ui, which is ui is the average of the gradient descent. As example, size minus by 1000 divided by 2000. So that's we get the gradient descent like this. That's all for this.
Okay, moving on to the fourth question. It asks about to explain the two cost function. Okay, so in the cost function, we can assume y equal to 1 and y equal to 0. Okay, firstly, if y equal to 1, the cost equal to 0 if prediction is correct, as h theta in bracket x equal to 0, cost equal to infinity. Then captures intuition, if h theta in bracket x equal to 0 but y equal to 1, we will penalize the learning algorithm by a very large cost. Okay, and next, if y equal to 0, the cost equal to 0 if prediction is correct. As 1 equal to h theta in bracket x equal to 1, cost equal to infinity. Then captures intuition that larger mistakes should get larger penalties.
Okay, hi. My name is Nur Hazwani binti Izlan, and my metric number was B0217101666. So I will discuss the tutorial 5, which is to explain the cost function with regulation. As we can see, what is regulation? Regulation is a method for automatically controlling the complexity of the learned hypothesis. And the idea is when penalized for large value of theta j. And then it can incorporate into the cost function j. And it works well when we have a lot of features, each that contributes a bit to predicting the level. And then we can address issues such as overfitting by eliminating features, either manually or via model selection. Okay, next, we move on to the, for intuition of cost function of the house. Okay, the first the first graph was the of size of house that which is theta naught plus theta 1x plus theta 2x squared were like this. The shape were like this, and then we put this into this theta and use this equation, and then we're supposed to penalize and make theta 3 and theta 4 really small. The 3 and theta 4 really small. Like this. Okay, like this. And this we put it here, and then we can see that theta 3 and theta 4, we assume that it's a 0. And then using this equation, we have to move on to the what had the hypothesis. It has a small value for parameter theta naught, theta 1 until theta something. It is a simpler hypothesis and less prone to overfitting. And then for the housing, the features were x1, x2, and until x something lah. And then the parameter is theta naught, theta 1, theta 2 until theta something. And then using this equation, we know that where lambda is the regularization parameter, lambda is more than 0, and then means that it's a no regularization on theta naught. That's all from me. Thank you.